So yes, so James did a talk. James, who is speaking next to me, he did a talk like on a meetup a month ago or two months ago, I forgot, about things that you could implement with ES2015 Proxies. And I was at that meetup. Who else was at that meetup? Okay, one guy. Okay, cool. And I thought, wow. So I have heard about. I had heard about ES2015 Proxies, but I thought I never looked into it because it was never something that I needed. It was never something that I thought I could use for solving problems until James did that talk. So my talk is pretty much the same talk as James did, but with other examples that I came up during his talk. So this is what James presented on his talk. A bunch of use cases there. And I'm going to do this: an ORM, seamless immutable library, and a spy like you would use in mock in Sinon, for instance. So what are ES2015 proxies? For everyone else except that guy who went to James's talk, because yeah, I have a link to James's slides here. He spends a lot more time explaining ES2015 proxies than I will, so you should definitely check out his talk. It's a great talk. So to do a very quick recap, I think ES2015 proxies is a very underrated API. Like who has heard of it? Yeah, first of all, who has heard of ES2015 proxies? Okay, cool, bunch of it. Who has used ES2015 proxies? 2 people. Okay, yeah. I think we could find like a couple of use cases. Most of it is going to be debugging, I'm afraid. But I still think it's like very underrated, and no one looks into it, and no one cares about it anyway. So here's an example of what an ES2015 proxy looks like. This is like a getter and setter. Before we dive into it, let's have a look at. Let's have a look at what that code actually does. So if I grab this. Let's grab this, and I'll explain the whole thing later. But if I fire Node, can everyone? No. Better? More? More? It's okay? Cool. So if we grab that code and put it here. So we have this object, this one, which is an empty object now, and then we have a proxy that defines some, well, get and set, let's call it traps for now. I'll explain what that means in a moment. But we define get and set traps for this proxy onto this object, and let's have a look at what happens with that. So if I do P, which is my proxy, the instance of my proxy, which is the instance of the proxy class. If I do p.a equals 1, and you see that I'm basically setting a property on this proxy, and I have a trap that says when you're setting, it logs setting property to value on target, and then actually does set the property on this line here. I press enter, it does, so it does, first of all, p.a equals 1, which is setting the property, and logs also setting property a, which is this one, to 1, which is the value on the target, which as of now it's an empty object. So I basically I used like the very normal, very usual JavaScript API that everyone has been using for ages, which is object.value equals something else, and I got an interceptor that logged that message and still did an action on it. That's mostly in essence what proxies are about. And now if I do p.a, p.a and see let's see what that does. So it logs first getting property of target, which is an object that has a which is 1, and then it outputs 1 out of this operation. So basically I used like two very familiar APIs that everyone knows, which is getting and setting up properties on JavaScript objects, like the same way that everyone's been doing that for ages. But I managed to intercept the calls and then do some actions like that, logged some messages, but it could be anything, of course, and then I did what I needed to do. In this case, for instance, is this line here. It's setting the property on the object. So that's in essence what proxies are. So you have something on top of your actual object. Well, actually, let's have a look at. So let's have a look at this thing and see what it's now. What it is now. Yeah, it is what the proxy also is. Oh, okay. Proxy is something else. Has some getting, inspect, and something, but it's also this, which we expected. So that's mostly, in essence, what proxies are about. They're about defining a wrapper of an object that you can intercept things that you couldn't intercept before with very simple JavaScript APIs, basically. So again, that's the code. That's the code that we just executed. Here I'm defining a property hello, which has the value of world. This should log setting hello to world on empty object. And then if I console.log p.hello, it should log getting hello of this object. And that's what we saw on the code demo. So the question is, why do we need proxies? Well, how would this be useful? Do we really need them? No, we don't need proxies. I think everything that we can do with proxies we have already been doing for ages. All of these things that I'm going to show you guys on this talk has been done. We have them. It's something. It is a new way of doing it, but it's not something that was impossible before. And that's basically it. It lets us do things with a very clear API. So using JavaScript objects as we are used to using them, but being able to intercept calls and do some other things on them. So just so we can follow, you guys can follow this presentation better, and because only one guy went to James's talk, let's put names onto things. So when you define a proxy, you instantiate it like this. So new proxy, and proxy is a global object or class on newish browsers that implement ES2015. So it's like mostly everything now. You set a target, which should be the object that you're proxying, and then a handler. A handler is an object that has of which properties are traps. Traps are interceptors of operations that you can do to this object. For instance, you saw just on the example a while ago that I set the traps of set and get. And then when I get and set properties of this object, it would trap the calls, do some things that I wanted to do with it, and then proceed on to the next things. So that's it. A proxy takes a target that you are proxying to, and a handler, which is an object that has methods which are traps. That's mostly it. And these are all the traps that you could do in ES2015 Proxies. So you could trap all of these methods. The most important ones, I would say, so the ones that I find myself using more often are get, set, delete, apply, and that's it. You cannot see it very well, but those are bold, but yeah. And these are links that you can use to read more about it. It's basically two resources. There's a very good article on Google Developers by Adi Osmani, and of course the reference on MDN. These sites are published, and you can access them right now if you look for me on GitHub. I'll tweet a link afterwards. So now on to the actual talk. So on to the actual implementing more stuff with ES2015 Proxies talk. First of all, the first example, like other than the examples that James implemented on his talk, I thought about seamless immutable. So seamless immutable is this library that you use in JavaScript to prevent mutation from happening on objects, because that has side effects and other things, and it could make your program do funny things. So there's this functional programming school that I'm sure everyone's heard about that said, oh, you shouldn't mutate objects because side effects and things. And sometimes you want to enforce it, and then you would use this library or just immutable. So this is an example of the immutable library README. It basically goes through defining an object and an immutable object, and then trying to mutate properties. So for instance here, you see that it's trying to redefine the first element of this array, or the second element depending on where you're counting from, to some other string, and it still logs immutable, which is the first string the first property that we defined on this array. So again, on the second set of lines, it's trying to redefine another property, and then when you log it, it still shows you the second property. So how would we implement this with ES2015 Proxies? This is an easy one. All we need to do is ignore property setting, right? When someone tries to set a property, you say, I don't know, I'm not setting this property, I don't know. So let's have a look at some code. Again, this is part of the presentation repository, so all of the code that is here you can access on my GitHub, and after the presentation or during should be there. This is the presentation folder. If you go to the GitHub repo, this is what you'll find. So the first one is seamless immutable. Let's have a look at this. Can everyone see it? Mm-hmm. Cool. No? Okay. Is that all right? Cool. So I guess this is what you would need to do, right? Define a proxy to an object, and when someone wants to access this property, wants to set a property on this object, you say like, I don't know anything about this, that's it. You need to return true, because that's how you tell the proxy implementation on browsers that you successfully set a property. If you return undefined, or if you return false, it will throw an error. Actually, you can see this. First of all, of course you don't need this, you just need this. Oh, not that, yeah, this. Let's have a look. So I have some tests here, very simple tests. So we import just the file that we were having a look at. We start an immutable we instantiate an immutable object with with this base object, and then we try to set the property a to 2, and then we verify that it is still equal to 1, which is the immutable object that we started with, and we do a deep equal to see that the object that we started with is still a1, and that's it. So let's have a look at what happens. Okay, cool, it passes. So let's have a look at what happens if, oh, by the way, I didn't mention, but whenever you omit traps on the handler's object, it will do the default things that it does with the regular usage of JavaScript objects, of course. So if you omit all traps, it will be just a plain object, just as you would expect to use. Here I'm only defining like a custom action for set, which will not define a property, and that's it. So for instance, if we let's say, if we do a function that doesn't do anything, because you could think, all right, my immutable doesn't need to do anything. That's all it needs to do. Like on the set trap, it should do nothing because I don't want to set a property. Let's see what happens here. It says error thrown in test. Trap returned falsish property for property A. Well, returned falsish for property A. So that's it. You need to return true on your sets, and I think deletes as well. If you want to let the proxy API know that your operation succeeded, and that's it. So let's go back. Okay. Function that returns true and does nothing else. And that's okay. That's all we needed. Of course, you can extend this. I don't think this will do a deep immutable. Of course, you could do more stuff here with Lodash and things to make it like truly deeply immutable, like the regular immutable library. Let's do more stuff. So another thing that we could do is an ORM. So ORM, of course not. I'm not going to implement a full ORM on this thing. I don't have the time. But we could do an object that we back it by a store, a backend store, and support create, read, update, delete operations. That would be like a quick, fun use case to show at a meetup about proxies. I bet a full-fledged ORM could be implemented as well, but who has the time, right? So this is what I think we would have to implement. It's record property setting, initialization, getting as well, and deleting, and replay these actions on a database. So let's look at the code. For this one, I tried to keep things as simple as I could. So I started with a function that accepts a backend because I wanted the backend to be pluggable on this thing, so you could implement backends on whatever database you want. And then this function accepts an object that you actually want to put in your backend and have a proxy onto it that will replay whatever getting and setting properties you do with it. And then it starts by defining an underscore ID, the way that MongoDB does it. Yes, if you try to set these properties to something else, things are going to go bad, of course, just like in MongoDB. I think MongoDB wouldn't let you do it. I could set like some protection to not allow you to do it, but this is a meetup talk and it was done in 30 minutes, so that was it. So we start by cloning the object, having an underscore ID property attached to it, and then saving it on our backend. And then, well, doesn't matter what backend we have, but I implemented a memory backend. The memory backend accepts a store, and this can be like any pointer to a JavaScript object that you have in your program. And this is what it does. It does like very, very simple stuff. It saves an object just by setting the value of this. Well, store would map like IDs to objects. So saving this object, which is what happens in the start, would save the object to the store by referencing its ID. Getting the object would obviously go to the store, say like, okay, I want the object with this ID, please return it. But get this is a special get, like this is a get by a property, so it gets the property of that object. And then set does something like slightly more complicated, which is clone the object, set a property on it, and then save it to the store and return true. Cloning the object because I think we don't want to mutate objects that the client implementation is passing on to this functional programming stuff. And delete property with side effects. And delete property does the same thing, so clones the object, deletes the value, the property of the cloned object, sets the cloned object without the without the deleted value in the store, and then returns true. And that's it. That's our memory backend. You could implement this in any database you would want. This is very, very simple operations. So let's have a look at what happened. All right, this is a bit more complicated, but do you guys want to go through this? No, right? No. Okay, cool. No. Okay, cool. Okay. Initializing this object. So you start with a store that it's, as I said, is a pointer to an object in your Node.js application. So I'm creating like an empty store here. Then my backend is the memory backend, and I pass the pointer to the object here. My create, read, update, delete is something that I'm going to make out of my backend. Then I'm going to start by saving my object on that. I don't think the naming on this is correct, but I didn't have a lot of time to prepare this presentation, and I found that I was getting very blocked here, and I couldn't find good names for things. But basically, I save an object onto the store, I get the ID out of it, and then I'm going to verify that the object that I have in the store, if I access the store directly, it's not the same object. So it's not actually referencing the same object. That's very important. Like, I want to save it somewhere, not just referencing the same object. And but it is pretty much the same object. So it's the same object, but it's not. So it's the same object, but it's not.
Same reference.
It's not the same reference, but it's the same object. Thank you. And it's the same object that I have in store plus the ID that I assigned to it. So testing the get method is pretty much doing that as well. I'm verifying that when I get a property of this object, if I access the store directly, it's still the same property. Setting is doing the same thing. If I save an object and then afterwards define a property on it, if I access the object in the store, does it have the property that I just assigned? Yes. And delete as well. If I delete a property of this object, did the same action gets replied in my object in the store. So if all of these are true, basically I have this very, very clear API that behaves like an object, where I can set a property, get a property, delete a property, and of course read a property, read a property, or read the whole object, the same way that I do it for any JavaScript object, except this gets saved onto a store. So instead of like going through those ORMs that everyone does, which makes you call object.get property, you could just do object.property like you do with normal JavaScript objects. Feels more natural, basically. This test will pass. I ran them before. You guys can clone the repo and have a play with it. It's nothing interesting. Well, but since I'm in the folder, I guess. Yay! Okay, cool. And the last one is a spy. So a spy is so if you guys do testing on JavaScript, sometimes you want to make sure that a function was called. So imagine that you pass a callback somewhere or something else, and you need to make sure that what you implemented is going to call this function. perhaps with some specific arguments, perhaps a couple of times. That's mostly why we get spy, and usually from Sinon. I think that's the most popular spy mocking library for functions. So what do we need to do? I think we just need to do a proxy that records function calls, right? Function calls, perhaps the arguments, and if we can assert that a certain function was called with certain arguments after the fact, the same number of times we expected, with the arguments we expected, and had the return values that we expected, then our implementation of something is behaving the way we thought it would, right? So let's have a look at that. Oops. So I think this one's the simplest one. So we just defined one trap. If we go back to the list of traps, this was one of the ones that we could define, which is apply. Apply gets well, you get this function, this trap executed when we proxy to a function, and we either call the function or call the apply method of the function, which is pretty much calling the function with some arguments and the this argument, or we call the call method of a function, which is the same thing but takes the arguments instead of an array as separate arguments. So this is all we need to do. We need to well, the apply trap gets called with the target, which in our case is a function, and the this argument is the this that you want to pass to the function, and an arguments list is, of course, as the name suggests, the argument list. Everyone could guess that one. The only thing is that this spy library accepts a function, and if none is passed, we will default to a function that does nothing. I just thought that it would be nice because the Sinon spy also does it, so why not? And basically, when we get the trapped call to apply, we will do first compute the result that the actual function would get out. Using target.apply, why not? Because target will be a function, and this function will have an apply method which we can pass the this argument and the arguments list. Very plain stuff. And if we were done by right there, what we would have would be pretty much a proxy that does nothing else, nothing special than just calling the function as you would normally. So this would behave the same way as a function that you would pass there. But besides that, and before we return the result, we want to first toggle a flag that says that this function was called, increment the call count, so the number of times this function was called, and why not have an array that saves the arguments list and the results. If we want to inspect that after the fact and see how many times was this spy called, and with what, and what was the result, and then finally return the result so we can proceed with our testing. And this gets instantiated with 0 values pretty much for all of this, and that's it. So let's have a look at the test. So the test starts by, so this is the use case with no function. If you can use the Sinon spy just like this. So you start with just by starting a spy. Right after we get our spy, it hasn't been called, and of course the call count is 0. Then we call it 3 times, just like you'd call a normal function. And then we can assert that the spy has been called indeed. This should be true, and the call count should be 3. This is if we do dot only. Oops. So if we do this, that should be okay. Cool. That means that we start the spy, it hasn't been called, then we call it 3 times, then we assert that it has been called 3 times. That's how a spy should behave. That's how the Synon spy behaves. And the second one is when you pass a custom function onto it, and that's why we are calling the apply method of the target with the specific arguments and the this argument. I didn't go overboard with this test. I wanted to keep it simple, so I didn't use any specific this argument, but I'm pretty sure it will work. You guys can try it at home. So we define, okay, we define a sum function that is going to whatever argument you pass onto it, it's going to sum all of those and get out a result. It's using a reduce method. Then we define a spy to this function, and again we start by verifying that the spy has not been called. The call count is 0, of course, and now it's interesting because we're passing arguments onto it and we want to see results. The calls object of this spy is an empty array. Then we call it 2 times, once with 1, 2, 3, and we expect to get a result of 6 of this one. Oh, it's right here. Okay, cool. We expect to get a result of 6 of this spy call, and then we call it with 4, 5, 6, and we expect to get a result of 15. And then we verify that it has been called. It was called 2 times, and the arguments list and the results. So the calls object has arguments list and results of both calls, and this is how it should look like. So it was called first with the arguments 1, 2, 3, and we got a result of 6. The second time it was called with 4, 5, 6, and has a result of 15. And we basically can do that with this very, very simple JavaScript. Oh, missing semicolon. I was working in a team that didn't use semicolons, so everything's upside down in my head now. So this is how it should look like, and we get this using like this very, very simple JavaScript API, which is calling functions. Let's have a look at that. Cool, that's good too. So that's it. That's pretty much Synon spy implemented as ES2015 proxies, and I bet that's a lot less code. So yes, possibilities are endless. My time is not. I bet everyone can think of a lot more stuff to implement with ES2015 proxies. I thought of this during James's talk. Hopefully someone can make another presentation like this one on the next meetup with some more stuff. Now, an interesting topic. Can this ruin JavaScript for everyone? Yes. How? So imagine like someone, or you are using an object that you get from somewhere, like some library, anything. Anything that returns an object, and you get this object, and you think, this is a JavaScript object. Of course I should be able to access a property, right? Because like, what could break by accessing a property? Well, now it can, because this object could be a very, very transparent proxy that if you use it like you would use anything, and you don't expect anything crazy to happen, because like, if you didn't know about, let's be fair, like if you didn't know about ES2015 proxies, you'd be pretty sure that nothing could break if this object was a JavaScript object, right? Well, but now it can. If you don't inspect that this is a proxy beforehand, now it can break your code. So that's it. Fun stuff. And that's it. This is me. You guys can find the slides here. That's all. Does anyone have any questions? No questions? One question?
Can you run it in the browser?
Yes, you can. You can run it in, well, this is pretty old actually. Like, it sounds like it's new, but it's not new. It's very old, but it was ignored. So I think even IE11 has this stuff. I think it's pretty old. You'd be fine running it in the browser, most browsers. Anything else? Yeah.
Are you aware of anyone re-implementing Synon with this?
No. But you could. But there's no reason to do it, because it's already implemented. But you could. Just for fun.
Can an object tell it's been proxied?
Can an object tell it's been proxied?
Yeah.
I don't know. No, it cannot. This I tried. Can I tell it's been proxied? Yes. If I basically there's a few markers on a proxy that would tell you it's a proxy. I think you can do. I'm not sure about instance of actually.
You can't because proxies don't have prototypes. So,
Ah.
I can't remember which area in particular, but it throws an area for you to try to do instance of.
Well, we can verify this. So.
Depends what version of Node you're using as well. In Node 6, you'll get false, but in Node 8, you should actually get an error.
Wait, this was
a reference error actually.
Oh. Yes, you do not.
No,
you cannot have instance of a proxy. So yeah, you cannot verify. But if I do this, look.
That's true, but I mean, I'd probably like deprecate it with like an extra property or something.
I guess, yeah. But I guess if you inspect this doesn't say it's a proxy, but it definitely says that it's not the actual object, right? Because you have these other getters or something.
You can see the methods that are intercepting.
I don't know if. Yeah, I think you can. No, I don't know. Yeah, I don't know. But this is what you get, basically. Not sure. Yeah?
How do you decide between using proxies or using property descriptors? Because you can create getters and setters using property descriptors as well.
I think you'd go for property descriptors, but if you have this, again, like these are not proper use cases. If you are trying to debug an object that you don't know how it works, and or yes, and you don't care about how it works, but all you want to do is like know when a property has been accessed or set, then you could just use proxies to log that and actually do the action afterwards. And then I guess only proxies can do that for you, not property setters and getters. Maybe you can, I don't know. Not sure about that one. More questions? Yeah.
Do you know of any usage in common libraries where we can go and see what they do with it?
Common libraries? No, I don't know of any common library using this, to be fair. Again, I think this is very underrated and no one cares. And it's not like it's solving an impossible problem. Yeah, I don't know. And then there's like the browser compatibility issue, of course, or the engine compatibility. Don't know. Haven't seen it myself. Any more questions? Cool, that's all then.
Thank you very much.
Okay.